Great to be here with you again. This is Julio from AWS. We're going to continue our conversation about the AWS well-architected framework today. So if this is the first time you're joining, AWS well-architected framework is designed to help you guys build applications that are cloud ready and that comply with the best practices and design principles that we've seen as successful in many customers and that we can establish as good things for everyone. So this is divided into 5 pillars. You can download this white paper, the AWS well-architected white paper from the website. And the idea here is this. It's divided in security, reliability, performance efficiency, cost optimization, and operational excellence. So in the previous episodes, we've been talking about security, reliability, performance efficiency, and now we're going to talk about cost optimization. So today's episode is all about saving money on the cloud. So let's jump right into that. So it starts on page 30 of the document. Here in the bottom, you can see the cost optimization pillar. And let's just review the design principles before we jump into the questions. So the first thing is adopting a consumption model and designing your architecture to pay for only the compute resources and the storage resources that you're actually going to use. And benefiting from the economies of scale and price reductions and many other things that are only possible in the cloud and on AWS. And stop spending money on data center operations. I know you guys don't like to spend too much money on tin cans, so we are all going to leverage the best of the cloud. And it's not just about spending less, but being able to analyze and dissect and understand better our billing. So we're going to take a look at that aspect of costs today as well. And of course, using the managed services can help to reduce our total cost of infrastructure. So this is the general ideas that we'll go through every question. And starting with the first question in the cost optimization pillar, the thing is, are you considering costs when you select AWS services for your solution? And the idea here is that different services will have different price criteria. And in many cases, you can do very simple steps to take advantage of one specific service. For example, in storage services, this gets pretty clear. If we take a look in the S3 pricing, we can see that it starts from 2.3 cents per gigabyte on standard storage. And this is object storage, you know. You don't have a file system on S3. S3 is not a hierarchy, not like a traditional file system at least. So this is a bit different. You can't just take an existing app and say, hey, use S3 instead of my file system, but you can use third-party software. For example, in WordPress, there are many plugins to write directly to S3. And the difference is that instead of having a file system, for example, our file system as a service, EFS, will charge you 30 cents per gig per month. So this is 10 times more than you would pay for S3. And just the difference of perhaps installing a plugin, or instead of writing to local disks, writing to S3. So selecting the right cost structure and perhaps adjusting your app to leverage the best service for your costs will be pretty important. And have to think about this in every tier of your app, right? And select the price that sounds right. So this is what this first question is all about, like how for each tier in your app, you should describe what is the service that you're looking for and how it makes sense to use that. For example, and this happens in many other cases. For example, let's take a look at databases. If we take a look at RDS pricing, we can see how this can go on in literally any service. Take, for example, MySQL. If we are running on an on-demand instance on MySQL and we get to a certain size, say, for example, R3 large, this costs 24 cents per hour, and this is just single AZ. If we go to multi-AZ, and that's probably what you want for production, to have synchronous replication in different locations, the same instance type will cost you 48 cents. So keep this number in mind for now, because if we change a database to Aurora, it is MySQL compatible, so we can probably switch from the app without any code change, just point the app to Aurora and have it running. And if we check, the DPR3 largest on Aurora starts on 29 cents, and it already includes like 6 replicas out of the box. So this is way more cost effective than running your own MySQL on RDS. And the things go even more dramatic if you consider MySQL on your own instances. And sure, let me get the PDF. So we are talking about well-architected. This PDF, you can get it on well-architected framework, AWS. This is the page, and the link is right here. So let me paste this for you guys. So this is the documents that we are talking about. And feel free to ask questions. And if anything I say doesn't make sense, either because of my weird English or anything at all, just comment, and it would be great to dive deeper or explain anything better. Okay. So let's get back to our document. It's on page 33. And the second thing is, have you sized your resources to meet your cost targets? So the thing is, I see on many customers this problem of how to start. And if you don't know, I highly recommend starting with the minimal. If you're on EC2, for example, on-demand pricing, you can see that we have a range of lots and lots of instances that goes from less than 1 cent per hour up to dozens of dollars, perhaps. And well, if you can get away with a T2 Nano or a T2 Micro, why not? So you're going to have to experiment and try different instance types and take a look at how those things work to make the appropriate selection for your costs. And the idea here is taking a measure of performance and cost and seeing like what's the sweet spot for your app. And we're gonna take a better look at this in the following questions. So this is the idea for picking the appropriate price model to meet your cost targets, because we have lots of options. For example, let's talk about compute, about AWS compute services. We can start with EC2, and let's take a look at EC2 pricing. We have 4 options on EC2: on-demand, reserved instances, spot instances, and dedicated hosts. So on-demand pricing is the simple pricing that you get when you spin up an instance and just pay by the hour. So if you don't do anything special or different, this is simply what you pay is what you use per second, in fact. So the prices are listed per hour, but the actual billing charges are now per second. So you can just pay for a very small fraction of what your compute times would be in most other circumstances. You can pay exactly for the instance time that you use, but there are other options as well. For example, on reserved instances, we can get some discount by just paying in advance or making a commitment of usage with AWS. Let's pick one instance type to work today as an example. So let's say that we've done some experiments. We've talked about how to try performance and how to make performance experiments on the last episode. And let's say that we arrived at the decision that we need an M4 extra large. This is the ideal for our app. And it's very easy to make the math because it's 2 cents per hour on demand. So let's say that we have this for a full month. How much does it cost? 2 cents per hour for a full month? Well, one way to solve this is using the AWS calculator, calculator.awsamazon.com or AWS calculator if you can't type like me. So this is how we can estimate our AWS charges by the end of the month. So if we have one instance that's used 100% of the time and it's an M4 extra large on this region, we can expect our bill on demand to be around $150 per month, okay? And this changes a bit if we go to reserved. So on the reserved instances model, let's take a look at the reserved costs for M4.x large. And pricing details, pricing page. Oops, this is it, the RI pricing page. And M4.x large. So this is the deal right here and there. So one thing that I like about this is there's no special pricing or special deals. It's all very straightforward and public on the web page. And here's the thing. The more you commit to AWS, the more you get a discount. So if you don't make any commitment and just pay by the second, the cost is 2 cents per hour. But if you go to, if you can commit in, for example, for 1 year, you can pay $517 upfront. It's immediately after you commit. And after that, per month, you pay $43, an effective hourly rate of 1.18 if you divide, which would be a significant discount, 41% over the 20 cents per hour that you would have otherwise. But if you can do a 3-year commit upfront, and for many enterprises, this is ideal as you can just pay upfront and don't worry about how much it will vary. It's more predictable, and this may be interesting in some cases. You can just pay $2,000, almost $2,000, and your monthly costs goes to zero. So you only pay upfront. And this is an effective hourly rate of 7 cents. It's a 62% discount. So the idea here is that if you know that you're going to need this capacity, for example, you need a minimum capacity to keep the website up, even if it's at night. You need to stay up 24/7. You can take this capacity and reserve it. And the other traffic that you might have occasionally, you can spin up and spin down instances on demand and just adapt to your circumstances. So let's see what kind of difference this can make. So instead of, let's see with 2 instances, instead of just buying 2 instances, that would be almost $300, you can get, say, hey, wait, I'm going to take one of this that I'm going to need and reserve it, and I will use one on demand because I don't need it 100% of the time. So say you have a high traffic on the day usage, as it's very typical, people getting to work during the morning and leave at night, and by this time it's a third of the day, 33%, you get more usage. So this can be on demand, but the other M4 large, M4X large, you can use it on 3-year all up front and just pay in advance. And this would bring your monthly costs to a much, much lower rate that you would have otherwise. All right, I hope this makes sense. And this is how you can select. This is what this question means, right? What are you using on demand? What are you using reserved? And now let's talk a bit about spot instances. So the idea of spot instances is having a fluctuating price. So here on the EC2, let's just go for spot instances and see how this works, trying to spin a few of them. And here in the spot requests, by the way, reservations and spot, you can do everything here from the console. You don't need to call anyone on AWS, just follow the wizard and that's it. And I'm going to submit a request for our M4X large. And here I can set, this is the big difference. I can set a max bid. I can set a max price that I'm willing to pay for this instance. Say I'm not willing to pay 20 cents. I will offer at best 15. And the idea here is if the current market price is less than 50 cents, say for example is 10 cents, I will pay 10 cents. I will pay the current market price. If it fluctuates up to 15 cents, I will pay this amount. But if it goes over, such as 18 cents or even 25 or $1, it can go way above the spot, the on-demand price, then your instance is just terminated. So this is important to consider, like how your application behaves if one instance is terminated. If it's consuming for a message queue or doing a big data batch, it's probably not going to be a big thing because you have other instances consuming work and they will be fine. But if you're taking web requests, perhaps you want to take this instance out of the load balancer first and things like this. And we do have the resources to automate that, but you really need to consider your application architecture. But if you can handle termination or stop and start of instances, then you can take a lot of advantage of the spot market. See, let's pick from this month on one specific AZ, say this green AZ here, or just the green one. So we can see that most of the period, most of the time, our spot market was in this range, just above 6 cents, 5 cents, and here a bit more, 5.5. So here, for this whole duration of the month, up to this point, you've been using an instance that would cost up to 20 cents on demand, and now we're using it for 5 and 6 cents, except for this peak here where it reached a top price of, it's like around near the 8 cents, 10 cents, somewhere around here, but you get the idea. And if we go to a higher range of time and for other AZs, we can see a very different scenario. For example, in US East 1A, the market price actually went up almost above $2, so way above the. Thanks, Jermaine. Hope this can be helpful. We're going to talk a lot about many cost optimization tips today. So this is sure to save some guys a lot of money. In this case of spot, for example, one thing to consider, what would be better for you? If you need to buy, let's say that on average here we would be, 10 cents or 8 cents. Let's say it's 4 times cheaper, for example, on average. What would be better? Do you think it's better to buy 100 on-demand instances for sure, or 400 spot instances with a chance of variation? So you can see that probably the sweet spot would be to get 50 instances on demand and 200 spot for the same amount of money on average. And this is how you can save a lot of money on spot. And we have a lot of customers doing this. Let me show you guys one very cool example is from a company called Cycle Computing. And they built this supercompute cluster. And when you have HPC clusters or distributed computing, you kind of need redundancy because computers are going to fail all the time if you have enough of them. And it's no different with them, but let's see what they did. So their case is for simulations. They did material simulation and to simulate 200,000 different materials, and they had at peak 150,000 core clusters. So this is probably one of the largest computers in the world. And the cool thing is, if they were to build it from the start, it would be an environment worth 68 million by their estimates. And they just ran the simulation for 18 hours, and it costed 33,000 on spot. So this is kind of huge savings for them and for many customers that need this kind of scale. So sure, this is the link for the Cycle Computing article, okay? And we're going to talk a lot more about this. So this is Spot, and we are going to have a full episode on Spot to understand the differences in the request types. I'm just showing how different compute can be. And the final cost in EC2 is, we talked about on-demand, spot, reserved, and dedicated hosts. Dedicated hosts allows you to know which host is serving each instance, so you can license Windows software or any software that requires you to know the exact number of cores, physical cores, and things like this. So this is just mostly for licensing and for busy neighbors and things like this that you may have on shared compute. If you need dedicated hosts by any reason, another one is compliance. So some compliance standards doesn't allow you to share hardware, so you may need dedicated hosts for this, and this is available. It actually costs a bit more, not less, but it's good that you can use it. And again, it's all per second now. Everything is reserved, spot, everything works the same. It's just the same price per hour, but billed per second on EC2. Okay, so this is just for EC2, but we have to consider other models of compute. For example, we have to think that this is per hour per second, but on Lambda, this is pretty much cheaper, because on Lambda, you're not spinning instances, it's serverless. Instances are managed by AWS, and just upload your function and go. And you only pay for this weird unit of costs called gigabyte second. It's 0.00001667 per gigabyte second. So if your function stays up for 1 second and consumes 1 gig of RAM, you pay this fraction of a cent. And if that's all it took to respond to your HTTP request, for example, or to your DynamoDB entry, or for a new S3 file, whatever triggers your function, you pay for only this. If you're idle for the rest of the night, you don't have to have the instance up, so you don't pay anything else. And this is huge for cost savings. I'm trying to get at least one customer example for each one of those. And for serverless, the best example I have is this talk from Lynn Langett. I highly recommend you check her out on Twitter. She's one of my favorite speakers. And in this talk from NDC Oslo, Serverless Reality or BS, she tells the story of the Australian census, and it was a project built by a government contractor, and they spent $9 million trying to get the Australian census online, and they failed. Like, it couldn't handle the load. On the first day, it went down, and it was terrible. And a week later, 2 students at a hackathon did a screen scraping of the website and did the exact same thing using serverless and Lambda for $500. So we are seeing many cases of customers that had costs in the dozens of hundreds of dollars going to the dozens of dollars, because they just can adapt to demand and only pay for the time that compute is actually happening. So you can use this for answering HTTP requests, building code, responding to events, scheduling tasks, and anything that you can run on Lambda. So this makes costs very interesting. Let me paste this link here. So this is Lynn's talk. Highly recommended. And you have to think that compute is not the only cost here. You have network and bandwidth as well. So usually data transfer cost, it's nothing for data coming in from the internet to AWS, but for data going out from EC2 to the internet, it starts at 9 cents per gigabyte data transfer out from the EC2 to the internet. You have a gig free, but after that, it's 9%. So there are a couple ways to make that easier. If you're really starting and all you need is one instance, we have light sail that's a bit more predictable because we have these packets. So light sail is pretty much like EC2, but instead of paying per second, you're paying per month. So if you want just a virtual private server for $5 a month, you get 1 terabyte of data transfer and more predictable pricing. If all you need is that single WordPress instance, and this make it quite cheap. All right. But other than that, the only other ways to reduce costs are one way would be to use the Direct Connect. So we have this service called Direct Connect that you can connect directly to your data center, and of course If you're not going through the internet, this would reduce your bandwidth costs because you don't need to go through the VPN and things like this. You can just connect directly to our data center. But I'd like to talk about the most important service for cost optimization, and that is CloudFront for sure. And what CloudFront allows you to do is use a global network of edge locations to cache and respond directly from the edge, what is not only more efficient in terms of performance, but in terms of cost efficiency as well. So let me show you guys what it is all about. So this is definitely the high point of today's episode. This is I think the most dramatic cost optimization we can have. And I will go from the very start to make sure that everyone gets it. So here's the map of AWS that you can see on awsamazon.com/products. And here you see two different kinds of infrastructure. We have these yellow dots, those are the AWS regions. And we have these yellow dots that are the AWS edge locations. And the difference is that only the services that require the minimal latency runs on edge locations. Most specifically in this case, CloudFront, our content delivery network. So the idea, just to make sure everyone gets it, let's go step by step here and ask this simple question. What is the ideal AWS regions for you guys to pick? You know, if you're building an AWS app today, right now, what is the AWS region that you should pick? And it's kind of a difficult question to answer because the first thing that comes to mind is distance and latency, right? You pick the one that's closer to you because you would have the least latency. So if we take this cloudping.info, this is a third-party website that you guys can use. Here's the link on the Twitch chat to measure the latency between your current network and the near and all AWS regions. So here you can see that from my current location, I have around 100 to 200 milliseconds up to the US and 9 milliseconds of latency to São Paulo region. Guess where I am right now? So I'm not at the data center. I'm in another location, I swear, but 9 milliseconds is pretty good. So should I use São Paulo region? Is this what I should pick? Well, this may be a good idea, but not so fast, because let's go back to S3 pricing, for example. And here on S3, we have standard storage on 2.3 cents per gigabyte. We have infrequent access storage for 1.25. And the idea here is that you have a 1.9 less of availability in the SLA for infrequent access. So this is the best for backups and things that you don't need to be accessing like hot online on your web app. You only want to archive some data on S3 and use it, for example, for big data processing or batch tasks or things like this. This may be, or backups, this may be ideal. And for cold data, for data that you really hope that you're never going to use, such as data for auditing purposes or even very old backups, you can use Glacier, and this is the cheapest we have at 0.4 cents per gigabyte. And the hard thing here is that when we change this to a different region, for example, in Brazil, this changes a bit. So I'm gonna swap here for Brazil, and you're gonna see that we have a 4 cents 0.05 price point in Brazil, and we don't have Glacier yet. So the price and availability is different per region. And this is the problem, this is one of the problems that CloudFront solves. Because if you have your content cached around all these edge locations around the globe, yeah, you don't need to go back to the region in every request, because most of them should be coming directly from the edge locations. So you can, for example, use a region in the US and use the global network, including the 2 edge locations in Brazil, to deliver content at local latency. So you would have the best of both worlds, the best of latencies and the best of costs, except on that first request. So if someone in Brazil asks for the content and it's not on the cache, it would fetch on the remote location. But even though the network links between the edge locations and the regions are more efficient than the internet links that you would have otherwise, that could go through the weirdest routes, and this makes it much more efficient to go through CloudFront. How much so? You have to think that for every request that is responded directly by CloudFront, it will not reach our load balancer, it will not reach our instances or Lambda functions or databases, and this can save a lot of money. So I have a chart from a customer that can give us a better idea of how this works. Let me just find it just a second. And just in a bit, I have this file somewhere, I know. So here it is. So here is the bytes transferred to viewers graph from CloudFront from one customer. This is real production traffic. Thank you for Estratégia Concursos, a customer that lent us this demonstration. And here you can see they are sending to their viewers about 7.5 gigs every day, sometimes less, sometimes more, but on average 7.5 gigs, 7 terabytes and a half, in fact. So in the end of this month, they had like 91 terabytes of traffic delivered in total, right? But you see that from misses, like the cache misses, the requests, the traffic that actually were not found in the cache and had to hit the backend, it was 5% of that. So 91 terabytes of total traffic, only 5 from misses that were not in the cache and had to go to the origin. So you can see this is a huge improvement. You can serve, I have seen customers serving dozens of thousands on micro and small instances, just because most of the traffic doesn't even reach instances anyway, and queries are cached. And if you think the caches in all layers, from the CDN layer and in your web server and your Elastic Cache or Memcached or Redis, wherever you're using as a database cache, and if you optimize those layers of cache in your architecture, this can make this very big difference. And this first layer, the CDN, is really crucial for this. So you get the benefits of being hosted. You don't pay for most of the requests. For the requests that actually go to the origin, it can be the most cost-efficient origin for your app. So this may make, again, a big deal, right? And so I hope this gives us an idea how to select the appropriate model. And how do we make sure your capacity matches but does not substantially exceed what you need? So this is pretty important to understand. And to demonstrate it, I'm going to show on Elastic Beanstalk. So let's create a Beanstalk app just to see how we can adjust this. So if you don't know Elastic Beanstalk, it's a very easy service to launch applications. I will create a new one from the start. And well, I will just use the wizard and spin up a new Java app, for example, with default settings. And this is all it takes. It will spin up a new environment and create everything I need. And it makes very easy to change the configurations, for example, changing instance types and things like this. But for this cost operation, what we need to take a look is scaling. So really try to understand your application behavior and pick the appropriate trigger if your app is CPU intensive or memory intensive, or if you have latency, you can create monitors and auto scale for that. But if you have a seasonal app, you can also trigger time-based scheduling and specify in which periods of the day or with recurrent schedule with cron expressions you can spin up and spin down instances as you need them. Excuse me. And this is how you can adjust if you're handling services yourself, like auto scaling, be it with triggers or time-based scaling. And of course, a much better idea would be to adapt to serverless and let AWS take care of it as events go, functions are executed, and you don't even need to care about the underlying instances. And that's probably much more efficient than you would be able to do yourself. So this is the idea for answering this matching costs. Okay. So the next part is has been about cost planning. So we've been talking about budgeting. We saw how to use the calculator to create budgets and how to compare prices across services, and especially how to leverage the global infrastructure and the CDN and the network services to reduce costs. But we have to also think on the other side of this, how to measure expenses and how to have visibility into those accounts. And first, considering data transfer charges, as we saw on we discussed this, the kinds of network traffic and the network traffic costs. And if we take a look at the CloudFront costs, one special thing about CloudFront pricing is it is the only service that you have reserved and volume discounts for network traffic. So here you can see the transfer costs on CloudFront per region, and you can see that for high volumes of traffic we have significant discounts. It's the cheapest service to deliver traffic, and you can reserve capacity. So if you need 10 terabytes per month, for example, you can make a deal and commit to that in advance, and we offer volume deals for that. So if you have high volumes, I highly recommend everyone to go to CloudFront. And even if you don't, just to think about it from a security standpoint, just to think that an attacker, for example, on DDoS would have to take down the whole network of edge locations before reaching my instances, it's a no-brainer. Use CloudFront. That's it. And well, this is it for data transfer charges. and how you're monitoring your usage and spending. So one key aspect here is Trusted Advisor. We've been through Trusted Advisor in other episodes. If you go to support, and I'm sorry, but this is just for those of you who have premium support, so check if you have business support plan. And this costs about $100 per month, and I highly recommend it. You have better and faster answers, and better. I highly check out the page for more information. But the killer feature for me is Trusted Advisor, because you have automatic cost optimization tips. So if we go to my account here, I have checks being automatically executed, and I can see that I could be saving $200 here because I have EC2 instances that are not being utilized. And it even shows me what are the AWS instances that are not being utilized fully. I have underutilized EBS volumes, and you can RDSs. It checks for everything. So make a habit of going through Trusted Advisor and checking, at least understanding why it's complaining and saying that. You probably could use a smaller instance type or tune your auto-scaling groups and things like this. And another important tool to understand spending is your billing dashboard. So in your billing dashboard, we can see monthly spend by service, spend summaries, create budgets, see tags, and perform cost analytics on our accounts. And one device that I recommend everyone to turn in is billing alerts. So I have 2 billing alerts here. I will create one more just to show everyone how to do it. So just create an alarm and get it on billing. So I will just say that when I have unexpected estimate charges of, I don't know how much, $20 per month, let's say that, call me on 20. And when I go over this amount, I will send this to a new list to fermanj@amazon.com, for example. And this is the admins, the cost admins, and this is all it takes. So I have to confirm on my email address, but as soon as I do, I will be notified every time that I go over this amount, and this is all it takes. And another very important thing is to make sure that you're using tags. So in every part of AWS infrastructure, you can set tags and say, hey, I need this to be different. Let's say I cannot edit after they're done. Let me see if I can do this on the EC2 instance directly. So here, let's see if I have one instance running, and I can go to tags and add tags. And the idea here is that I can say this is from the cost center. Any key value pair is all right. So devrel, or for example, that the owner of this is Julio, or the environment is prod. And then you can see on the cost allocation reports, you can activate here I'm on a IAM user, but I would be able to fetch this data and see how am I doing per owner or per cost center or per environment, and break my bill as I please. And of course, on the Cost Explorer, we can see the monthly spend by service, by account, by view, and dive deeper and understand how much each service is costing, and filter by service, by account, by region, and group, or even download this data into Excel or into Apache Spark or whatever R or whatever you want to use to analyze your spend. So this is make sure you use the billing dashboard, and here is where you can see all this information. And there are certainly many partners in this space, so with cost tools and things that you can run. One simple one, just as an example, is Netflix Ice. So Netflix Ice is an open source project to track usage and see how a different cost dashboard, let's say. So Netflix Ice, I guess. Yeah, so it's TVT Ice right now. So it will give you like this kind of view, this kind of usage dashboard. So it will just parse the same CSVs, the same data that we are throwing in your buckets, and just see it from there, right? And do you decommission resources that you need to stop or they're temporarily not needed? And this is pretty important, and there are many ways to do it automatically. One that I highly recommend is the janitor monkey. So Netflix has this open source monkeys to test for resiliency and test for fault tolerance, and one of the least known bots they have is the janitor monkey. So let's search for Netflix, and here is the idea. It can look for resources that are not being utilized and just kill them. And especially if you're using containers, for example, and you have some flexibility on the underlying hosts as horsepower and divide your containers as seen fit, you can just, for example, scale up, move workloads to new services, and shut down containers and have the janitor monkey automatically clean the instances and things like this, or even other resources, and this is just an idea. You can probably automate with the AWS tools and SDKs to do the same. And you, again, use auto-scaling groups, not only to scale up, but also to scale down. And this would be how to decommission resources that you no longer need. And one very special case on this is dev and test. So if you think about dev and test, it's not 24/7. So if you only use dev and test for the weekdays and for the work hours, you really can save a lot of money just from shutting it down on the nights and weekends. So the known working hours can be 1/2 to 2/3 of the time, and 2 days a week is also a significant percentage that money you can not spend just by shutting down dev and test when they're not being used, right? What access controls and procedures you have to place and govern AWS usage. And here is 2 different services on that, AWS Config and AWS CloudTrail. So AWS Config is a way to monitor the configuration and inventory of resources. So here you're gonna get notified every time a resource changes and the configuration changes, if the network changes, and you can make sure that's adequate to your cost constraints. And on AWS CloudTrail, you get not the state vision, but the events vision. You have one entry, one log for every AWS API call your apps and users do. So you get a record of everything that happens on your account. And you could possibly reconstruct this into Cloud Config, but you don't need. You have Amazon doing this automatically. But if you use the AWS config for the config view and the AWS Cloud Trail for the events view, this would make it easy to control usage, because those resources can trigger Lambda functions. So you can trigger a Lambda function every time a new instance is spin up, or every time auto-scaling group changes, or anything that's cost sensitive and you want to know about it. For example, if you have on one particular auto-scaling group that's growing too big, or Lambda functions that are getting near your limit and things like this, you can understand it in real time by triggering those Lambda functions in response. So this is how you govern and do this in real time. And you have to always be looking into new services and on AWS/new, because it changes a lot, especially with cost reductions. So we've done many of those for these years, and they are always up on the blog. The last one was in the middle of this year, but here you can see that we are frequently reducing the costs, and this is part of this AWS wheel of costs, right? The more we drive down costs by efficiency and scale and automation, we grow and get more efficient at handling this, and we pass this to customers through cost reductions. And when we do that, we attract lots more of customers and becoming more attractive. We need to get more scale and reduce costs and spinning this wheel over and over again. And I guess this is why this is how cloud works, and it can say how it saves so much money, right? And I guess that this is pretty much it. I hope that next time we're going to talk about operational excellence. And just as a takeaway, probably the most important tips. Let's go over as a takeover. Let's see the three most important things, in my opinion, would be: number one, use CloudFront. So on AWS, Amazon products, always remember this map. You can have local latency and the best costs using CloudFront, and offload your backends and be more secure. And this is the best cost advice I can have. The second is picking up the most effective model of costs. So if you can use block storage instead of file systems, if you can go serverless instead of servers, and if you're doing servers, use a composition of spot, reserved, and on-demand to make sure you only pay for what you're using. And the third would be to monitor your costs and take advantage of Trusted Advisor and the Billing Dashboard to help you and everyone in the company, especially the executives, to understand how much money AWS is serving them. And as a bonus, a fourth, the thing that I believe saves the most is in human terms. For example, in RDS, we were speaking earlier about multi-AZ. Or for example, machine learning is even better. You don't need to be a PhD in machine learning or hire one just to ship your data and have predictions. So if this is all you need, you can use the higher levels of managed services and go on adding value to your app. But if you care enough to go deeper, you can do Spark on EMR, you can do FPGA, you can dive to the lower levels for sure. But the more you use the abstract servers and the managed services, the more cost efficient your architecture is going to be. So this is it for cost optimization. It was a pretty quick broadcast, but those are really the most important things. And next time, see you for operational excellence, and we're going to see how to be unbreakable. Okay? All right. Thank you, guys. If you have any questions or anything at all that you would like to see on the future broadcasts in this channel, please ping me on Twitter or here on Chime anytime. Let me just paste you I'm JM Fairman like this on Twitter or here, and FairmanJ at Amazon. At Amazon.com. Anytime. Just let us know what you think and what you would like to see on these talks, and we are here to help you guys be successful with AWS. Keep tuning in. Thank you very much for watching. See you next time.